Let's walk through the C++ program step by step. At the very top, we see the task description in comments. It tells us that the goal is to design a simple car using C++ classes. Add some behavior like displaying information and drawing it with ASCII art, and then extend that design into an electric car child class. We start by including the IOStream library and setting up using namespace std. This is what allows us to use count directly for printing text to the console. Now, here comes the heart of the program, the car class. In object-oriented programming, or OOP for short, the class is the main building block. It's like a custom data type that lets you bundle together data and behavior into one unit. Inside the car class, we see three public data members: color, which is a string, speed, measured in kilometers per hour, and fuel, measured in liters. Because they're declared as public, we can set their values directly later in the program. Next, we see two methods inside the car class. The first one is print_info. This method prints the car's color, speed, and fuel. It's an example of encapsulation. The car itself knows how to describe its own state. The second method is draw. Instead of just printing numbers, it actually draws a tiny car using ASCII art. This is a playful way to show that a class can also include behavior that isn't just raw data. Now let's look at the second class, electric car. Notice the syntax here. Class electric car, a public car. That little a public car is inheritance. It means electric car is a child of car. It inherits all the public members and methods from car: the color, the speed, the info printer, and even the ASCII drawing. But electric car also introduces something new, a battery property, measured in kilowatt hours. It also adds its own method, print_battery, which outputs the battery size. This shows how inheritance helps us reuse existing code while also extending it. In OOP, this is one of the biggest advantages. You don't need to copy and paste everything. You build on top of what already exists. Now let's move down to the main function, where everything comes to life. First, we create a car object called myCar. We set its color to green, its speed to 200 kilometers per hour, and its fuel to 60 liters. Then we call print_info, which displays this information. And after that, draw shows us the ASCII car. Next, we create an electric car object called Tesla. This time, we set its color to blue, its speed to 150, and its battery capacity to 75 kilowatt hours. Notice that we didn't set a fuel value here, because an electric car doesn't really need gasoline. We call print_info, which still works because it's inherited from car. Then we call print_battery, which is unique to electric car. Finally, we call draw again, and since it's inherited, the electric car still gets the same ASCII look. So, what's the bigger picture here? This example demonstrates three of the main ideas behind object-oriented programming. 1. Classes. Car and electric car are custom types, combining data and methods. 2. Encapsulation. The methods like print_info show that behavior and data are bundled together. 3. Inheritance. Electric car reuses everything from car while also adding new features. C++ supports both structs and classes, and while they look similar, classes are usually the go-to when you want not just data, but also rules, safety, and behavior. For example, you could make members private and control access with special functions, which prevents bugs and keeps your program more robust. And the real power comes when you scale this up. Imagine hundreds of different vehicles, trucks, motorcycles, electric buses. With inheritance, you don't have to reinvent the wheel. You just extend and adapt code. That's why OOP is such a valuable paradigm for large applications. For more videos, Don't forget to subscribe.